Hello, everyone. Good afternoon, Miss Duff and fellow colleagues. I hope you are all doing well today. We are excited to present our topic, which focuses on sample size and errors. Before we begin, I'd like to take a moment to introduce my wonderful group members of Group H. We would have worked hard to put this presentation together. I would like to introduce Miss Aaliyah Peters, Miss Eliot Perry, Miss Janae Caesar, Miss Malika Headley, and myself, Miss Jamacy Trotz. We want to thank you for your attention and we look forward to engaging with you as we delve into this important topic. In this presentation, we will explore sample size, its importance, the factors influencing it, and sampling errors. By the end, you will understand how to determine sample size, different types of errors, and how they affect your study outcomes. My colleagues and I will then delve deeper into these topics and explain them to you in more details. Before you dive deeper into the concepts of sample size and errors, let's start with a fun riddle to get your minds working. Hmm, I'm not too big and not too small, but I need just the right amount to make the perfect call. If you take too many, you waste time. But if you take too few, your results won't climb. What am I? I'm going to give you guys a few seconds to think about this riddle, and then I'll get back to you guys with an answer. If you would have stated sample, you're absolutely correct.
Good evening, everyone. My name is Miss Alia Peters, and I will be discussing what is sample size and what are the importance of sample size. In research, sample size refers to the number of persons, or we can say a population included in a study. Choosing a part of population to use to test the hypotheses about the entire population.
Let's discuss the importance of sample size. Several factors are crucial in ensuring the quality of a study power, reliability, resource efficiency, ethical principles, and their influence on findings. Let's talk about study power. Study power ensures the study can detect meaningful results. A study with enough power can identify true effects and avoid false negatives. Reliability. This ensures the data is consistent and trustworthy, allowing for accurate and reproducible results. Resource efficiency. This helps maximize results while minimizing the use of time, money, and effort, ensuring an optimal study design. Ethical principles. These guides researchers to follow proper standards, ensuring the sample size is adequate and participants' rights are respected. And finally, these factors affect the influence on the findings. A well designed study with the right sample size leads to valid, accurate results. In summary, these elements ensure a study is effective, ethical, and produces reliable conclusions.
Three factors that influence sample size are 1. Population size. The size of the population being studied is an important factor to consider when determining the sample size. A larger population generally requires a larger sample size to achieve a given level of precision. For example, let's say a company wants to conduct a survey to determine the satisfaction level of its customers. With 10,000 customers, the company wants to determine the sample size needed to ensure that the results are representative of all its customers. In this case, a sample size of 400 to 500 customers would be appropriate to ensure that the results are statistically significant and representative of the entire customer population. Number 2, confidence level. The confidence level refers to the degree of certainty or reliability we have in our conclusions based on the sample data. The higher the confidence level, the larger the sample size needed to achieve that level of confidence. Some common confidence levels are 90%, 95%, and 99%. A 95% confidence level is the standard in most research, meaning you are 95% certain that the results are representative of the population. For example, if a researcher wants to conduct a survey with a 95% confidence level, they would need a larger sample size compared to a survey with a 90% confidence level. A higher confidence level would require a larger sample to ensure a higher degree of accuracy and reliability of the results. Number three, margin of errors. The margin of errors, also known as the acceptable sampling error, is a key factor that influences the sample size in a study. It tells us how much we can trust the results of a survey. The margin of error help us to understand the range of possible true values. It's like a safety net for your data. A smaller margin of error required a large sample size to reduce the uncertainty and increase the accuracy of the results. How to determine sample size? Sample size can be determined using formulas or online calculators, considering factors such as population size, desired margin of error, confidence level, and estimated population proportion. Here is a common formula for sample size calculation, where the N is the sample size, Z stands for the score, which is based on the desired confidence level, P is for the estimated proportion of the population, and E is the margin of error.
Let's say you want to interview how many students at a school like Blanton Chip. However, you decided to interview 50 students at random during the lunch period. Only 30 of them would have actually received and completed the survey because the remaining students were either absent or they didn't respond in time. After you would have analyzed the responses, you realize that majority of the students who completed the survey enjoyed planting chips. However, this doesn't reflect the entire student population as not all students were able to participate, leading to inaccurate results. This is a typical example of sampling error, since only a portion of the sample completed the survey. The finding doesn't fully represent the preference of the entire student body. So, what is sample error, you may ask? Just to put or to give a definition of sample error. A sample error is the difference between the results you get from a sample and the true values from the entire population. You may ask, what does this mean? When we conduct research, we often don't study the whole population, just a smaller sample from it. Since the sample is just a part of the population, the results we get from it may not exactly be the same as if we studied everyone. Now you may ask, why does this happen? You need to understand that it's a natural part of working with samples instead of the full population. The sample won't perfectly match the population, so there will be some variations or errors in the results. Now we will look at the factors influencing sample error. When we talk about sample error, several factors can influence its occurrence. The first factor would be unavoidable. Sample errors is inevitable in any research. No matter how carefully we choose our sample, there will always be some variation between the sample and the true population. This is just a natural part of the statistical analysis. Next is sampling variability. Because we are randomly selecting a subset of the population, there will always be differences between each sample. Different samples from the same population can give different results, leading to variability in the data. Number three, sample size. The larger the sample, the more accurately it reflects the population. With a small sample size, there is a greater chance of error, as the sample may not fully represent the diversity of the whole population. Representation. A sample must accurately represent the population. If the sample isn't representative, for example, if certain groups are underrepresented or overrepresented, the sample error will be higher and not reflect the true characteristics of the population. Now, we need to understand sample errors help us interpret data more accurately and improve the reliability of our results by designing better sampling methods. We will now look at the types of sampling errors. We will look at random sampling error, sampling bias, non-response error. Here we will be looking at random sampling error. You might ask, what does that mean? Now, a random sampling error is the difference between the sample's result and the true population values, which occurs due to the random nature of selecting a sample. You must understand it is a natural, unavoidable variation in statistics. Let's look at some causes of random sampling error. The first one we have is sample size. Now, smaller sample sizes are more likely to produce larger errors. It's randomness. The random selection process can lead to a sample that doesn't fully represent the population. The variability. Natural differences within the population can cause variations between the sample and the population. Here we will look at an example of random sampling error. Let's say you want to find the average test score of 500 students in a school. You randomly select 30 students as a sample. However, the students selected happen to have higher than average scores. As a result, their scores doesn't accurately reflect the true average score of all 500 students. Let's break this down. Because a sample of 30 students doesn't perfectly reflect the performance of all 500 students, the average score of the sample differs from the true average. This difference is what we call random sampling error, which is caused by chance and the randomness of sample selections. Sampling bias. Sampling bias occurs when a sample does not accurately represent the population it is intended to reflect. This often happens due to systematic errors in the sampling process. These errors can lead to certain groups being overrepresented or underrepresented, which affects the reliability of the study. Now, we will look at an example of random sampling error. A researcher wants to study depression among undergraduate students and decides to send out emails asking for volunteers to participate in the study. Students are required to respond if they are interested. Only students who feel comfortable discussing depression or those who have a strong interest in the topic responds to the email. In this scenario, the sample is not representative because only students who are willing to talk about depression responds to the email. This creates sampling bias as it excludes students who may feel uncomfortable discussing mental health or those who are not currently experiencing depression. As a result, the study might give an inaccurate picture of depression among all students. To fix this, the researcher could use anonymous surveys or randomly select participants to ensure the sample better represents the entire student population. Now we will look at the types of sampling bias. Bias in sampling can occur in many forms, and it's essential to recognize these to ensure accurate and reliable research. The first type of bias we will look at is the undercoverage bias. This happens when some members of the population are not adequately represented in the sample. For example, online surveys often exclude people with limited internet access, such as the elderly or individuals from low income households. This results in a sample that doesn't reflect the full population, leading to inaccurate findings. The second type of bias we will look at is the voluntary response bias. This occurs when participants have the option to decide whether or not to participate in the study. For instance, in a study about depression, individuals willing to discuss their mental health are more likely to take part, while others may avoid participation. This skews the samples as it only reflects the views of a specific subset of the population. Finally, we will look at the non response error. The non response bias arises when some participants fail to provide the requested information or choose not to participate. This reduces the accuracy and reliability of the data, as the characteristics of those who respond may differ significantly from those who don't. For example, in a survey about job satisfaction, highly dissatisfied employees might be more inclined to respond, while contented employees might not bother. These biases can impact the validity of results and lead to misleading conclusions. To address these issues, researchers must carefully design their sample methods and encourage diverse participation to ensure their data truly represents the entire population. A researcher wants to survey alcohol consumption rates among college students. To do so, they set up a booth on campus where students can fill out a non anonymous questionnaire about their drinking habits. However, students who frequently consume alcohol feel uncomfortable providing personal information on a non anonymous form and avoid participating in the survey. As a result, the survey results show much lower alcohol consumption than is likely the case for the entire student body. To further break this down, the scenario highlights the issue of non response error. Since the questionnaire is non anonymous, it deters frequent drinkers from participating in the survey. These students are underrepresented in the sample, while those who drink less or avoid alcohol are more likely to take part. As a result, the survey fails to accurately represent the entire student population. The findings are unreliable because they do not capture the drinking habits of all students, leading to a biased conclusion. In surveys, two common types of non response can affect results: unit non response and item non response. You may ask, what is a unit non response? Now, a unit non response occurs when an entire unit, such as a household or individual, does not participate in the survey. This can happen due to refusal, being unreachable, or unavailable. For example, if certain households refuse to participate, the sample becomes incomplete and biased. The next one we're going to look at is the item non response. This happens when a respondent skips or refuses to answer specific questions, often because the questions are sensitive or the respondents lack knowledge. For example, people may avoid answering questions about income or health. Both types of non response can distort survey results, so researchers must work to encourage full participation and address sensitive questions carefully.
Good night, everyone. My name is Malaika Headley, and I will be looking at the impact of sampling errors on study outcomes. First, I will be looking at the bias sampling. Bias sampling occurs when a sample does not accurately represent the population being studied. This can happen when there are systematical error in the sampling process, leading to overrepresentation or underrepresentation of a certain group within the sample. Okay, so that means we will be having inaccurate results because it's not equal. You're either above, which is over representing, or you're under representing, and that will make the sample inaccurate, right? Inaccurate sample occur when the sample selected does not perfectly represent the population, leading to difference between the sample results and the population true opinion. And when you don't have the public true opinion, credibility will have to reduce because you're not being equal. You're either overrepresenting or underrepresenting, which will cause a question in our credibility. Ways to reduce sampling errors: increase sample size to better represent the population. And number two, use diverse and well designed sample metals.
Now that we would have gone through sampling errors and we are quite familiar with the types of them, we would have created a little group activity for you to complete. The scenario goes: a health researcher is conducting a survey to understand the exercise habits of college students. They send out online questionnaires to a random sample of 500 students, but only 15% of them respond. Among the 85% who did not respond, most are athletes who regularly exercise. This causes the survey result to lean more towards students who do not exercise regularly. Your first goal is to identify the sample error in the scenario. Then you will discuss how the sample error might affect the accuracy of the findings. And finally, you will list some effective strategies to boost participation in a survey. I'm going to allow you a few minutes to get your answers. Now, for question one, if you would have identified the sample error in the scenario as non response bias, that is absolutely correct. It is a non response bias, mostly because the athletes who regularly exercise didn't respond. The sample isn't representative of the entire population. The second question: how does this error affect the accuracy of the findings? Now, the findings will most likely overestimate the numbers of students who doesn't exercise regularly. This skews the results, making the survey inaccurate. And finally, you had to list some effective strategies that would boost participations in a survey. Now, we would have put together a list of things that we believe, a list of strategies that we believe would boost participations. The first one is insensitive. We could offer small rewards. You could also follow up on it, probably send emails or messages to the non respondents. You can also assure the respondents that their response will stay anonymous. You can make it convenient, keep the survey short and easy to complete, and then reach out to specific groups to ensure that there's better representation. Stick with your targeted outreach. As we conclude, it's important to emphasize that understanding the significance of sample size and the potential errors in sampling is crucial for ensuring reliable and valid research findings. To recap, we covered a few key areas. We looked at sample size determination. It's important to choose a sample size that truly represents the population so we don't end up making mistakes. Addressing bias and measurement errors. We need to work on reducing biases and measurement errors because that improves the quality of the data. Survey sampling best practice. Following best practices is crucial to make sure we select sample properly and fairly. By taking these factors into account, researchers can reduce errors, improve the accuracy of their results, and make better informed decisions based on the data. Does anyone have any questions? You can raise your hands or you could reach out to us, and any one of our members from Group H will get back to you. This brings us to the end of our presentation on sample size and errors. We want to thank you for listening and participating in our presentation.